Hey everybody, so we're still analyzing trusses. So if you're watching these videos out of order, make sure you watch the method of joints first. And now this is the method of sections. So this one is not as systematic. Like two people might do this differently. So let's say we have this truss, and let's say this beam looks rusty or something, and you want to know the axial forces specifically in this beam. So what we do is we cut a section of this structure through this member. So already there's more than one way to do it. Let me make a copy of this. So for example, we could cut through the beam like this. So we cut a section, let me just draw it like a line. So we cut a section like this. Or to cut through that member BC, we can cut through the structure like this. Okay, so if we cut a section this way versus this way, you draw each section of the structure. So for example, it looks like this, but it got cut here, and this beam got cut like that, and then AC got cut like this, right? And then on the other side, I won't draw it in as much detail, just draw it as sticks like this. It got cut here, and here, and here. So then what you do is you draw the free body diagram of each section. So for example, the section on the left, if I pick coordinates, let's say I'll pick coordinates like this. Then there's a pin at A, which I'll decompose into the components of that reaction. And then now there's this axial force in member AC. I'll just draw it in tension. This one here for member BC. This one here for BD. And for the other side of the section, it looks like this. And then there's the roller over here. Okay. And then let's say we cut it this way. So now the top section would look like this, the free body diagram of the top section. Oh, and I forgot to draw the loads up on the top. 400 newtons here, 800 newtons here. Okay, and then this is AB, this is BC, this one over here, CD, this one over here, DE. And then the bottom section would look like here, 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 there. And the reaction at A and the roller at E. Okay, so that's the method of sections. You cut the structure into sections and then you draw the free body diagram. And so you solve for the unknowns. You don't need to solve both sides of the section. You just pick one or the other because you're going to get the same answers for the axial forces anyway. But if you take a look at it, look at how I cut my sections. This one has 5 unknowns. The left section. The right section has 4 unknowns. So if I want to solve, the right section has less. If I cut it this way instead, notice the top section has 4 unknowns, and the bottom section has 7. So that's worse, right? So among these two choices already, cutting the section like this maybe was the better option because this looks like the winner. It has the fewest number of unknowns. The issue though is that's still 4 unknowns. At most, I can write 3 equations. So let's say I go with this section right here. I can write 3 equations. Let's do that. Okay, let's take a look at the geometry. Each member is 2 meters in length, so that means this has got to be 60 degrees over here, right? Theta. Theta is 60 degrees. Okay, so in the x direction, I had my coordinates like this. In the x direction, minus TAC minus TBC cosine of 60 minus TBD, that's it, equals 0. Y direction, TBC sine 60 plus E, the reaction, minus the 800 Newton load equals 0. And I can sum torque about anywhere. So let's say I sum torque about here. So that's point C in the joint C. So if I sum torque about point C, there's no torque from this force or this force about that point. There is a torque from here, TBD, and the lever arm would be this vertical here to here. Right, so how far is here to here? If this beam, like this hypotenuse is 2 meters, and this angle is 60 degrees, then this is opposite. So this has got to be, right, sine is opposite over hypotenuse. So then this vertical component here has got to be 2 sine 60. Okay, so that's 2 sine 60. And that would cause a torque going counterclockwise about point C this way, which happens to be the positive z direction. So this is positive. And then there's a torque from this force here, this way, in the negative z direction, so negative. And the lever arm from here to here is, right here to here, has got to be 2 cosine 60, because this is the hypotenuse, 2, and this is the angle 60. And this is the adjacent component, so 2 cosine 60. And then there's got to be torque from this force here going counterclockwise, so that is in the positive z direction, and here to here is 2. Okay, meters. Okay, so I have 3 equations, 4 unknowns. I can't solve it. So what should we do? Take the free body diagram of the whole structure. Okay, let me move this over here. Okay, so free body diagram of the entire structure. We don't care about the individual members of the structure. All we care is that there's a load here, and there's a reaction at pin A. If I pick coordinates like this, I'll decompose the reaction at A into its components. And there's a roller here at E. Okay, so I have, for the entire structure, 3 unknowns, and I can write 3 equations for the entire structure. Right, so in the x direction, in the y direction, in torque about anywhere I want, so let's say about point A. So the torque from this about point A is 0, here about point A, 0, here about point A is here to here, which is 4 meters. Going counterclockwise, which is in the positive z direction, so this is positive. And then torque by this is here to here, which is 1 meter in the negative z direction, so negative 1 meter, 400 newtons. And then the torque from this is going this way in the negative z direction, negative. And then here to here is 3 meters times 800 newtons equals 0. Okay, so if you take a look, 1, 2, 3 unknowns. Solve this for E, plug it in here, solve for AY, AX is 0. So now we have enough equations for the unknowns. Right, because now when we go back here, we already know E, we just solved for it right here. Now this is known. So then solve this one for BD, and then you can plug it in here, and we already know E, right? So you can solve this for BC, which you plug in here, and now you can solve for TAC. Okay, so this is the method of sections. Not as systematic, because like 2 people could choose different sections, and for example, I happen to analyze this right section. What if we looked at the left section? Could have done that too. So just for practice, I'll show you. Let me move it where I have space. Okay, so if we wanted to analyze this section instead, then we would still need to do this whole thing so we can get the reactions AX, AY, and E. So then at this point we would already know the answers AX and AY. Those would be known, leaving us with 3 unknowns, and we can write 3 equations, right? The x direction, this, let's go from here, AX, AC. The x component of this, we know this angle right here, right, is 60 degrees, plus TBC cosine that, and then this one. Okay, and then y, okay, here, AY, this, and the y component of this, minus TBC sine 60. Okay, and now some torque about anywhere you want. So again, these are unknowns. These 2 are known. So I would like to get rid of unknowns in my equation. So if I sum torque about right here, then the torque by this is 0. The torque by this is 0. So I think that would be a clever choice. Let me bring in the picture, the original picture. Okay, so if I sum torque about point B, then the torque by this, and this is 0. That saves me a lot. So then there's only torque from here, TAC, which the lever arm is here to here, here to here. This is 60 degrees, right? So here to here has got to be 2 sine 60 times TAC, which will cause torque this way, which is in the positive z direction, so that's positive. And then there's torque from this force, which is also at 2 sine theta. So see how this one and this one just add together? So I'm just going to add those together. Okay, and now there's torque from here, and the lever arm is here to here, which is 1. It's a 2 cosine of 60, which is just 1. And that's going to go this way in the negative z direction. So negative. Okay, so we have 3 equations for these 3 unknowns. Let me underline them. Here, here, here. Oops. Okay, so which would you like to solve first? You can solve this one for TAC. That's one equation, one unknown. Solve this for TBC. And then you plug AC over here, BC over here, and then solve for the remaining unknown. Okay, so that's the method of sections. It requires more practice. So I think however much time you spent practicing the method of joints, this one is a little trickier. So you may want to spend more time on this particular method. And then let me get to some more examples in other videos. I'll see you on those.